Hello, my name is Isa Pacheco, and I will be presenting my circuitry and coding for the Crosswalk Guard for Team CEWI Cumber. So to start off with, this is my circuit. It starts off with an ultrasonic sensor, and then it moves on to the Arduino Uno. And then here are three LEDs, green, yellow, and red, to show pedestrians whether it's safe to cross, whether they need to be cautious, which is the yellow, or they need to stop, which is the red. And then here is the piezo, which is used as a speaker to speak to pedestrians who cannot visually see the lights to let them know go, cautious, or stop. Then we have the transistor, which is used to manage current. And we have our push button, which is used for manual override if necessary. And then we have our resistors scattered throughout this circuit. Here is the coding. I'll scroll up. The first couple lines are just explaining what is connected to what, and that is telling the code, okay, so I know the components, I know where they're connected. Here, the bool override active. So this is basically explaining the push button system. So if the button is pushed, then the system will stop and it'll override, essentially. Here is the void setup. It's just explaining what's an output and what's an input. Here is the void loop. This is explaining pushing the button switches the system to active or override mode. And then here, it's stating that the code is stating that it sends a short pulse to the ultrasonic sensor to measure distance. Here is a quick calculation to convert the time of flight signal from the ultrasonic sensor and converting that into physical units that the Arduino can understand. And then this if statement is stating that if a car or a pedestrian is detected within 100 centimeters, then the buzzer will turn on via the transistor. But the else statement is stating that if a person or if an object is detected, it is not detected within 100 centimeters, that the buzzer will then turn off. And then here is a slight delay to prevent the circuit from overheating or from the loop running too quickly. I'm going to go ahead and start the simulation for you to take a look. 3, 2, 1. There it is. So as you can see, the lights turned on here and the wiring is all working appropriately as described earlier. And then, oh, my mistake. Let me just wait until that taskbar goes down so I can show you my other circuit. If it'll load. There it is. So we have the other circuit here. Uh, we have the Arduino Uno, a photoresistor to detect light, a resistor to manage current, and then our servo motor. Time to explain the coding. This is just the setup, what is connected to what. And then here is the meat and potatoes of the code. So when it's dark, how this is going to work is the photoresistor is going to detect headlights. And if a headlight is detected, the arm is going to go down and prevent pedestrians from crossing and getting hit, essentially. But if there is no light detected, then the arm will go up, hence the 0 and 90 mentioned here. And there is a slight delay in the code to prevent, as I explained earlier, issues with the loop running too quickly. So I'm going to go ahead and start the simulation so you can see how everything functions. As you can see, the gear here just shifted a little bit, like so. I'll run it one more time so you can see clearly, and there it is. So I would say the hardest part of creating both of the, well, mainly this circuit right here, was just, understanding the push button, the transistor. Those were the two things. Oh, and also the resistance that I needed to put for each resistor. I would say those were the most complicated um, components that I needed to add into the circuitry. That took me a little while to understand. But this was a very amazing project and I learned a lot. So thank you very much, and I hope you have a good rest of your day.